write a balanced chemical equation for this reaction. All right, so right off the bat, we know lead to NO3. Yes, that's what lead to nitrate looks like, and we know that's going to be aqueous. And then aluminum chloride, AlCl3, that's going to be aqueous as well. Results in AlNO3 and PbCl2, which is solid. All right, and to balance it, we're going to put a 3 here, a 2 here, 2 here, and a 3 here. Okay. That's our balanced chemical equation. And now part B is saying what volume of 0.25 molar lead to nitrate in milliliters is needed to completely form a precipitate when added to 3.62 milliliters of a 0.350 molar aluminum chloride solution. So it's basically asking how much lead to nitrate, what volume of this solution is required to completely react with no excess or no limiting reagents, all right? So in order to do that, we have to get the moles of aluminum chloride, right? Because it gives us enough information to calculate the moles of AlCl3, right? Aluminum chloride. From the moles of aluminum chloride, we can get to the moles of lead to nitrate. And then from there, we can use our molarity equation. So let's start off with 3.62 milliliters is equal to 0.00362 liters, right? Is that right?
Yes.
Yeah, okay. And we're going to multiply that by our molarity to get the moles, right? So 0.35 molar. And when we do that, we get what? What number do we get here?
We get 0.00. So we get.
I'm gonna say 1.267 times 10 to the negative 3 moles of AlCl3. Right, and from this, I'm gonna use a different color because now we're doing something different. We're gonna use our mole to mole ratio. So we see for every 2 moles of AlCl3, there's 3 moles of lead to nitrate that reacts. So 3 moles or 2 moles of AlCl3, aluminum chloride, and produce or reacts with 3 moles of lead to nitrate. All right. And from there we get 1.9005 times 10 to the negative 3 moles of PbNO3(2). Right. From there, we recognize that we have the moles of lead to nitrate. Right. We calculated that, and it gave us the molarity of the lead to nitrate. So we do write out our molarity equation equal to moles over liters. We're solving for the volume. So we solve for the volume, so we get liters is equal to moles over molarity. We calculated the moles, and that is 1.9005 times 10 to the negative 3 moles, and divided by the 0.25 liters or molarity, molar. And what we get is about 7.602 times 10 to the negative 3 liters, which is equal to 7.6 milliliters. Right? Did y'all get that? Okay. Any questions on that problem? Any questions at all? Right? So we wrote out our equation. We know how to do this. This is stuff we learned in basic chem, right? We solve for the moles of aluminum chloride here. We convert using the molar ratios, we converted to moles of lead to nitrate. We saw that we're looking for the liters of the solution of lead to nitrate. So we use the molarity equation. We have moles of lead to nitrate over the molarity of lead to nitrate, which will give us the volume of that solution, right? That's how we did that. And what is the mass of the precipitate formed? So what should we be using here? We know that either way we do it, we're gonna need some moles of one thing to go to the moles of the other thing. And since there's no excess reactant or limiting reactant, you can either use moles of aluminum chloride found here or moles of lead 2 nitrate. I'm gonna use the moles of lead 2 nitrate. Okay, so it'll be 1.9005 times 10 to the -3 moles of PbNO3(2) all over. And we know for every 3 moles, from this is from the balance equation, 3 moles of PbNO3 to 3 moles of lead 2 chloride are produced, right? And then we know that in 1 mole of lead 2 chloride, that has a atomic or a molar mass of 278.1 grams. And when you punch that into your calculator, you should get 0.529 grams. Okay. Next,
For part B, how do you know, why don't you need to solve for like a limiting reaction?
Yeah.
Because- because there's no limiting reactant, because it's saying you want as much, so there's no excess or there's no limiting reactant, because it's saying how much of this do we need to completely react with that? So there's, it's exact amounts, okay? So if, let me see if we could. So it's saying what volume of lead 2 nitrate solution is needed to completely, it should say completely react to form a precipitate, yeah. Must be a typo here. It's needed to completely react, and when we completely react, we don't have excess or we don't have limiting.
For
React.
that one thing, or like for
That one word,
like ALCL3,
yeah, what about it?
that would be completely,
Yeah, so we're completely using all of it, so there's no more excess, there's no excess reactant, everything, all the reactants are used up.
okay,
So there's no excess or there's no limiting reactant, okay? Because we're doing the exact calculation to figure out how much of lead 2 nitrate we need to react with this, exactly this amount of aluminum chloride.
So when it says completely, we don't have limited.
Yeah, like if it says, some compound A reacts completely with compound B to form this, that's always saying that there's no limiting reactant. Or sometimes it'll say compound A reacts in excess of compound B, meaning that you have more compound B than you need, so you're gonna have an excess amount of compound B. Okay, it says wording, we'll see some like that in this review as we go through. Any other questions on that? Okay. Next question we wanted to do was this is a gas one. So yeah, like I said, I only wanted to do one review of chapter 4 this time. And stoic.
Yeah.
We're gonna do more of that. Okay, so 50 grams of calcium carbonate is mixed with 500 milliliters of 2.5 molar HCl solution in a closed 1 liter container. Determine the pressure of the gas in the container after the reaction has gone to completion. The reaction takes place at 300. Okay, first, what we should do. What do we know about when an acid reacts with a carbonate or a bicarbonate?
Form hydrogen.
Wait. Carbonate or?
Um,
Okay, so let's write our reactants. We said HCl, right, is one of them. Reacts with CaCO3, no, okay. Calcium carbonate, right? Each one has a +2 and a -2 charge. So CaCO3 is reacting to form, what do we say about these types of
form of
reactants?
salts,
Form a salt, and that salt's gonna be what?
calcium,
Calcium chloride, so CaCl2.
form carbonic acid.
You form carbon dioxide. Remember carbon dioxide gas, and that's up here. I think I put it in here so you can review some of these things. So like general knowledge that you need to know are these 3. And this is on the review we sent you, also you don't have to take a picture. But if you want,
Put the, you send it by email?
yes, yeah. Yeah, so I didn't put the states of matter, but water is a liquid. Carbon dioxide is a gas. And your salt, okay. So let's go back to number 17. Okay, and then we said. And the last thing would be water. As our liquid. Okay. Yeah,
Thing for bicarbonate, like would it still form water and carbon dioxide?
yes, yeah. But the bicarbonate would be like HCl3, right? HCl3 minus. Okay. So let's go forward. Let's balance this first. So we're gonna put a 2 here. And then that should check out, yeah. Okay. Wait, no, that doesn't check out. No, wait, I'm sorry, we need to put a 2 here, not there. So that checks out then, okay, that works. Next, what should we do? Yes. Yes, okay. So 50 grams, let's start there. So 50 grams of calcium carbonate. CaCO3. That's ugly. Okay. And what's the molar mass of calcium carbonate? It's 100.078 grams for every 1 mole of CaCO3. And then we're going to go from moles of calcium carbonate to moles of carbon dioxide. And we see that there's a 1-to-1 ratio, right? For every 1 here, you get 1 mole of CO2. So 1 mole CaCO3 and 1 mole of CO2 equals 0.496 moles of CO2. So that's how much carbon dioxide is expected to be formed when you use 50 grams of calcium carbonate, right? So now we need to find how many grams of carbon dioxide would be formed given these quantities for HCl as the other reactant, okay? So how we should do that, clearly we need to use the molarity equation, right? So we have 0.5 liters times 2.5 molar is going to equal 1.25 moles of HCl. We put that over 1. And we use the molar ratio, right? So for every 2 moles of HCl, there's 1 mole of CO2 formed. And that gives us about 0.625 moles of CO2. Which one's the limiting reactant? Calcium carbonate or hydrochloric acid? Calcium carbonate, right? So what we're going to do here, let's just say CaCO3 is equal to our limit, is our limiting reactant, right? And you can just cross out this bottom portion so we don't get that mixed up, right? And next, what do we need to do here? And it's asking, what is it asking for? The pressure, okay.
So you just use Pivner.
Exactly. So this is combining a little bit of chapter 4 because you need to use the molarity equation, right? With gases. But let's go ahead and write our PV equals nRT equation. And what we're going to add here, we're looking for pressure, so we do P is equal to nRT over V. And then we add everything we have. So 0.496 moles of CO2, right? Times the 0.0821 constant. I'm not going to write the units out. This is at 300 Kelvin, so that's our temperature. And then what's the volume here? What do you think about this? The volume, 1 liter.
I mean, I would say, right, read the question very carefully.
What does it say? You have a container, right? 500 milliliters
Um,
is what, the solution, right?
Yeah.
So if this is 500 milliliters. And we know that the gas is gonna go up here. Then this second part must be 500 milliliters.
no, it's too much.
All right, so therefore. The volume that the gas occupies is only 500 milliliters or 0.5 liters, right? So 0.5 liters. Okay. Because remember, we have our solution down here. And the gas is not gonna occupy that area. The gas is gonna be up here.
The reason you know you're doing it for carbon dioxide is because that's the only gas.
Yes,
that's made.
correct. Yeah, because water is gonna be formed, but it's gonna be a liquid, yeah. And if we punch this into a calculator, you should get your pressure is equal to about 25 atmospheres.
I have a question that may be very silly.
Yeah.
What he was saying is we used to convert carbon dioxide because,
So we're using carbon dioxide because it's saying determine the pressure of the gas in the container, right?
and the only gas is there.
Yeah, and the only gas that's formed is carbon dioxide, right? Because this is gonna be stuck in solution, and water is a liquid, so it won't be part of that gas phase. Okay. Yeah.
If it asks for just like total pressure, like not of the gas, how would you solve that? Like, would you have to solve for all the products? And then
Well,
excess.
remember, what can only affect pressure?
Never mind, sorry, that was.
Yeah, you're fine, you're fine. Okay. Any questions, Maria? Are you sure? Okay. Anyone else questions? Anyone on Zoom questions? Okay, assuming no questions. Okay, so suppose the student mixes 2.34 moles of zinc metal with excess HBr solution. Predict the products and write a balanced chemical equation of this reaction. All right. Maria, you're gonna tell me what the chemical equation is.
This is zinc, so it's sand, solid, plus HBr. That's acid side years.
Correct.
I need to look at the zinc below hydrogen. On the reactant.
Let's just say zinc will displace.
Okay.
Okay.
So then you'll get zinc bromide. Which is zinc, it's aqueous.
Correct.
And then you'll get H2 gas.
H2 gas. There you go. That's the key thing. You need to know that when a active metal reacts with the strong acid, you're gonna form a salt and then hydrogen gas, right? That's the key thing about this.
Active metal with a what?
So like an active metal reacting with a strong acid. And again, that's information that's all up here. For y'all. These are things that y'all should make sure you know. Okay, so clearly we know that a regular acid and base form salt and water. An acid in an active metal is going to form salt and hydrogen gas. And the metal has to be more active than hydrogen, which is why I say active metal. And then acid and carbonates or bicarbonates form salt, liquid water, and gaseous CO2. All right. Where were we? If the student collects the gas in a 4-liter container and measures the pressure to be at 17 atmospheres, calculate the temperature of the gas. So how would we go about this? It didn't give us a lot of information. Or did it? Did it give us enough information? Of course it did. I wouldn't give y'all a question you couldn't solve. Okay, so with that, if we're looking for pressure, we need the ideal gas equation. Let's just write that down. If you don't know where to start, at least write this equation down. And then you can see, okay, actually, I might have that. I might have that. I might have that. We already have R, right? That's a constant. it's calculating the temperature, so that's what we want to know. Moles of gas, do we know moles of gas? We don't know moles of gas, but we know how much moles of zinc we started with, right? And it reacts with excess HBr to form product. So we can use a balanced chemical equation, which to balance this, you would put 2 right there. To figure out the moles of H2 gas produced. And then volume, it gives us the volume right here, right? 4-liter container. And then the pressure gives us that as well,
So you wouldn't do the thing we did last time,
which is what?
the like the 500 mLs when.
No, because that was implying. This one said, this, in a closed 1-liter container, there's 500 milliliters of a solution. And then it's implied that the rest, the other 500 milliliters is empty space. That was a trick question. I was really, when I was making this, I was like, you know what, how can I confuse them? Yeah, you have a question?
When we are solving ideal gas,
Uh-huh.
we always use ATM.
You should use ATM, yes, because the what's it called, the constant 0.0821 uses the units with atmospheres. If you were to use other units, you would have to use a different constant.
So if you gave us another one, we need.
You have to convert from like torr to atmospheres or millimeters of mercury to atmospheres. Okay. So back here, you're welcome. So 2.34 moles of zinc. And it's a 1-to-1 ratio, right? So 1 mole of H2 forms for every 1 mole of Zn. And that's going to give us 2.34 moles of H2. If we solve for T, we get PV over NR, give us T. Now we plug everything we have in here. Pressure was 17 atmospheres. The volume was 4 liters. We know our constant. And then we know the amount of moles of gas, 2.34. And that'll give us an answer of approximately 353.9 Kelvin. Did anyone else get that answer? Okay. Any questions on this one? I think the key thing about this question is you have to recognize, you have to know what happens when an acid reacts with a metal, or else you're just left kind of like, I don't know, you know, a salt and water is what you would be thinking. That's not what happens in this case. Okay. Now, because some of y'all learned this today in class, and everyone else, if you didn't learn it in class, you were probably here on Friday, you should know how to do this problem. So I'll give y'all about 30-45 seconds to solve this. That seems pretty reasonable. Right, Marie?
I just solved it.
See, 20 seconds. Didn't need more. Is that the one I'll send? Yes. Okay. Trust me without opening it.
I'm just making sure.
All right, it's been about 33 seconds, okay? So now, let's see. How are we gonna find density? Okay, the only equation I know of density is D is equal to M over V. That's interesting. How could I find densities in this? So,
Yeah.
okay, but do we know, we don't know D. I don't know where. So you're saying solve for M. But it's asking us to solve for D, so we have 2 unknowns here. Maria, what equation did you use?
I used Pidmer, and then I also took your advice and I memorized the actual equation for density with Pidmer,
Yeah,
which is pressure times molar mass over the constant and temperature.
nice.
What was that? Remember he
Yes.
showed us to the class?
So you memorize that?
Yeah, okay, it's easier if you just
Yeah.
memorize it.
it's pretty effective because 9 times out of 10, you'll be given, calculate the pressure of this grams of, or this mass of, gas. And instead of converting the mass to moles, you just plug everything straight in here and you're go on your way, okay? So from here, if it's asking us to calculate density is mass over volume, right? So right here is that D is equal to M over V, which is equal to P times the molar mass over RT, right? So we can just say D is equal to P times the molar mass, pressure times molar mass over the constant times temperature. Right? Now we just plug in everything we have here. We have 0.75 atmospheres, 32 grams per O2. Oh wait, that's not right. Yeah, more mass, yes. And then 0.0821. And then 453 Kelvin. Okay. And you should get around 0.64. What are the units for density? Yeah. Yeah, so Michelle says 0.65. I might have done some weird math, I don't know, but I got 0.64 grams per liter. And this is gonna be a multiple choice test, so if the answer is 0.65 and you get 0.64, clearly you know I probably used 32 instead of 32.0 or whatever, I don't know.
32.016.
Yeah, exactly. So that'll probably make a small difference. All right. So do we understand what we're using for that? Okay. Is that the kind of question he gave to y'all today in class, or was it?
Yes. It was similar, right? It was O2. Yeah, it was like
O2.
this.
Okay, cool.
It was actually a little bit more difficult for this.
Yeah, okay. We'll see if we have any other harder questions. Example of carbon monoxide gas occupies 3.65 liters at 298 Kelvin and 745 torr. Find its volume at this new temperature and this new pressure. Okay. So clearly, I'm gonna give y'all some time to work on this one.
So he
Yeah.
always never is gonna give us that compound. Always we have to solve it,
What do you mean?
like the carbon monoxide or like the equation.
There's no equation in this one because it's not a reaction that's happening.
No, but in the other one, so he never is gonna give us, we need to.
He
know
may,
as well.
but I expect that I'm assuming that we all should know how to go from the reactants to the products, because that's the whole chapter we did is predicting products, right? You're predicting precipitation reactions or double displacement combustion, all those. So we expect you all to know how to do that. He may give you the reaction sometimes, but don't count on that, okay? All right, where should we start here? Tell me what equation we're using.
1v1/T1 is P2.
What's the equation name?
Combined gas.
Combined.
Yeah, there we go.
No one can use that.
Always doing the most. Okay. So combined gas law, right? P2 over T2. Wow, I really gave y'all one in Celsius, one in Kelvin. Try that. Two.
Not he meant to do that for sure.
Yeah.
Maybe I did. Okay. So this in Kelvin is 259, right? Now it's asking to solve for the volume. So we're solving for V2, right? If we rearrange this to solve for V2, we get P1 V1 T2 over T1 V2. Wait, P2 is equal to V2. Okay. From there, we plug everything we have in. So
Hey, we don't have to go from torr to atmospheric pressure, right? They just have to be
no,
constant.
you don't have to because it's gonna cancel out. Everything, as long as your units cancel out, you're gonna be okay. All right. But in this case, we're not given torr, we're given kilopascals.
In this case,
Oh wait, am I on the right one? No, I'm looking at a different one. I was looking at number 20. That's kilopascals.
it's.
Okay, yeah, so in this case, it's torr. So you, as long as your units cancel out, it's gonna work out, okay? So from here, we have P1 was 745 torr. That was really bad, sorry. And then B1 was 3.65 meters. And then T1 or T2 was 300 or 259.15 Kelvin. Over T1, which was 298 Kelvin. So clearly our temperature is decreasing, right? 298 to 259 Kelvin. Would we expect the gas to expand or to? We would expect to decrease, but because other variables are also changing, you can't assume that it will, okay? So we'll see what happens. Let's see what our final answer is. And then what was the class variable P2? So 367 torr. And like I said, all the units cancel out. So torr cancels, kelvins, and you're left with liters. And when you do that, I get, Maria, do you get an answer? What do you get?
6.4.
6.44. So clearly, temperature decreased, but the volume increased. But that's because what else is happening? The pressure's also decreasing a lot. So you have a lot of fluctuations going on, which is why you can't predict the outcome of the volume in these scenarios. Okay?
So this means that pressure decreased more than volume, than temperature.
You read your chapter.
Yeah.
Oh, good job.
Do we have to memorize the reactivity series?
I don't remember having to memorize it. If there's anything that involves you needing it, it'll give you the activation.
Just to answer his question, on the pre-lab, Dr. Armand said that he would give us their activity series on exams.
Pre-lab is totally different from your class. Okay? So maybe for the lab, you need to memorize it, but for this class, what I remember is he said, if you need it, it'll be provided, okay? So yeah, that's, okay. 26 is the next one. All right. How about I give y'all a couple minutes to work. Oh, this one's has a lot of steps. All right. I'll give y'all. Maria, you look kind of,
Yeah, what the heck?
okay. Rich, you wanna explain this one? Try to follow here. I think the best way to go about it is to follow this order, so like number 1, 2, 3, 4. Okay. That's the best way, I think, when it comes to explaining. You look a little lost.
This is, I have never seen it before. Okay, Rich will teach us.
Of course you.
Yeah, I'll give you all some time to solve the problem. In the meantime, let's see if even I can.
Combine.
Combined gas law? No. The partial. What was this now? Just so that we
It's not partial pressure thing? Oh, man, I saw.
Yeah, I was waiting, like, I was waiting.
Oh, wait, I learned. I didn't.
Oh.
Oh,
I know that way.
what did he mean?
Who came up with the law of partial pressure?
You did.
That's
I
the
mean,
answer.
sort of, kind of, not really.
Well, this may be on the test, so who came up with the law of partial
Yeah.
Why are you saying?
Yeah.
Dalton, it's Dalton.
It's Dalton's law of partial pressure.
We haven't talked about.
Isn't
this
it Dalton?
in-
This is expected.
Dylan Dalton close enough.
That's what I'm saying.
It's
Just don't.
You were close.
Go ahead.
Same thing. We haven't solved.
Wait, why am I getting a negative pressure?
Oh no, that might not be good.
This-
You know how to go about this problem?
No,
And,
look, I know it's on Alex, I know to do eventually, but I didn't touch it.
Yeah, this is like,
Don't we also know effusion or something like that?
oh my
oh,
gosh,
yeah, but that one's not, there's a whole equation
what's the S?
with like a square root and everything.
Bro.
Yeah, I know.
Yeah, just because they don't have a whole lot of time to let you solve this out. Or I can do it.
I mean,
You know what, number one or number two?
Whoever can just teach me how to fix.
Okay.
It's really so mean.
Oh, we're just friends. Okay. All right, I'm gonna give Rich about 30 more seconds.
Stop pushing me.
Oh, wait, let's see, Audie, when you give up, that's when we'll go over, it, okay?
Or like a positive pressure.
By the way, you can't Quizlet these questions because they're all homemade.
So we're trying to try harder professors,
Have I what?
try harder than professors.
No.
We shouldn't get it all.
Will we get a key at some point?
Maybe like the day of the exam, but
No, the first exam I added, but she may never sent it to me.
I might have blocked you on it.
No, I did.
It's the spam.
I think I know how to go about it. I know how to go about it.
Now,
I know
now
how to do it.
when's his response?
I think I
All right, I'm gonna give y'all in the back. Couple more minutes. I think Rich needs a couple more minutes.
I mean, I'm.
Yeah, I don't know, that's what we need with the large, 26.
What did you do?
Wait, it has a total pressure. Why are they doing that partial pressure? Because this is a conflict.
It's too gas.
It's a conflict with. But it's not asking for.
Tricky one.
I recognize it's the partial pressure concept, I just don't know how to do it, so I'm just. Yeah.
Write something down.
Why is it like? Stressing me out.
Yes, I'm waiting for him.
Come on.
We got it.
Wait, I'm not.
Oh, wait, they got it or something, maybe, can we learn or something?
That's what I'm saying.
I'm about, I think
Take your time,
Dude, the whole solution's right there.
I know, but I need to make sure I know. How to do
Yes.
it. You put scientific notation on this.
Oh, wait.
I just need to type in. Like 10 lines.
That's what you got?
For one.
Moles?
Times 10 to the negative.
Or go- Wait,
That's
so
what you're
you're
solving for.
Yeah. Oh, you're following from most part.
Yeah.
I'm not there yet.
Look at you got the
What
same.
are you guys doing? What are you
We're
doing?
gonna- Okay,
Yeah.
all right,
I don't know.
I'm doing, well, do it this way. I think this way.
Yeah, that.
Yeah,
Just
I just use-
so that you-
You've used pivot for neon,
Exactly.
and then you get the pressure of neon, and you subtract it from total pressure to get
Alright,
the
go
pressure
ahead.
of argon.
All right, Rich is going to,
I not get that.
Maria, we're gonna explain this, okay?
All right,
Thank you.
so what would be step one, y'all think?
Yes,
Moles with
that.
neon.
Moles of neon? Yeah,
And
that seems to
two.
be Dylan's first step.
Oh,
Well, that, yeah, that was my first step. Okay, so you do 0.146 grams of neon, right? And then you look at your molar mass, so that's 20.18 grams in every 1 mole.
Oh my gosh. So
Solve that out.
when I did this, I might have been dumb, but I could have used what equation to jump straight to.
Wait a minute,
Oh my
Here, let's show them the trick, okay? Instead of doing it this way, let's show them the trick of the density equation. You plug everything straight in.
So 0.146 over 0.355 M over B.
Actually, read this. M over V is equal to.
760.
It's really the same thing as mass over volume equals pressure times molar mass. T. So then you get the pressure, right? Pressure is gonna be total pressure, so that's gonna be an amount of, first of all, let's make this X, because this is only looking at the grams of neon. So if we do the total amount, so if we do this, we get the total amount of grams. Ideally,
It was.
because this is the total pressure. Feel the total pressure, total molar mass, including sulfur.
Oh, I see.
Wait.
Or maybe,
I'm confused.
wait a minute. I might have. tripped it. Okay, here, so I
I
just-
mean,
we
the
just get
M
the
be
number-
over the, what are we trying to solve for that?
Yeah, so if we
Yeah.
give you the total pressure, you have to find the partial pressure of neon.
all right,
So this one.
Could've worked out.
I think so, but it was kind of, okay. Number one. I'm just gonna do it the way I did it, because maybe I was actually smart at the time. Let's find moles of neon, okay? So we use 0.146 grams. And we're gonna divide by the molar mass, which is 20.18 grams for every 1 mole of neon. All right. This is gonna give us 7.3 or 2348 times 10 to the minus 3 moles of neon. Right, that's step one. Step two, we want to find the pressure due to neon, okay? And we are gonna do that by using PV equals nRT. All right. And the way we would do that is PV equals nRT, and so we're finding the pressure, we're gonna divide by V, so P equals nRT over V. Right? So this is step two. And then we plug in everything we have, so 7.2348 times 10 to the negative 3 moles. And let me just get this over. And now we're gonna multiply that by 0.0821. And then we're gonna multiply this by the temperature, which is 308.15 Kelvin. And if we divide that by the volume of the container, which is said is 355 milliliters, but we know that is the same as 0.355 liters. So 0.355 liters.
Where did
And
we get the 308.6?
0.0821 is
Okay, I
the
got
constant, the ideal gas constant. All right, and we get a pressure of about, pressure of neon, 0.5155 atmosphere. Okay. That's the pressure due to neon only, okay? What we need to do is convert this pressure. We could either convert this pressure to millimeters of mercury, or we can convert this pressure to atmospheres. And I choose to convert this to atmospheres.
With the conversion, 760.
760 millimeters of mercury for every 1. Yeah.
So you divide that.
Divide what?
It's 626 divided by 6.
So what we're gonna do here for step 3 is take 626 millimeters of mercury. And we know for every 760 millimeters of mercury, we have 1 atmosphere, right? And why are we doing this step? We're doing it to get our units to be the same, right? Because here it gives us in millimeters of mercury, and we solve for it in atmosphere. So we have to have our units the same, okay?
Yes.
So that will give us 0.82368, which is equal to the total pressure, so P total, okay? That's step 3. Step 4, what we need to do next is utilize the principle of Dalton's law of partial pressure. So the pressure of one component plus the pressure of another component equals the total pressure. So in this case, we have neon and argon, right? So the pressure of neon plus the pressure of argon is equal to the P total. Okay. That's, let me zoom in here. So that's the Dalton's law of partial pressures. what do we have here? We're looking for the pressure of
Argon.
argon, right? Well, we're looking for moles of argon, but in order to figure out that, we need to figure out the pressure of argon. So, but we have this, we calculated this, right? It's right here.
Total.
And then we have the total, right? We just did that in step 3. So now if we solve for the P total, or for P of argon, pressure of argon, it would be the total, which is 0.82368 atmospheres minus 0.5155 atmospheres equals pressure of argon. When we do that, we get pressure of argon equals 0.30818 atmospheres. All right. So now to the final step. We know the pressure of argon. Now we need to just plug this back into our PV equals nRT, our ideal gas law. So PV equals nRT. We're finding the moles, so that we are going to solve for N. PV over RT is equal to M. And if we plug in all of our givens, we have 0.30818 atmospheres, and that's of argon, right? And the volume of the container remained the same, so it was 0.355 liters. And then the 0.0821 is our constant. And the temperature remains the same of, it's 35 degrees Celsius, right? So 35 degrees Celsius, so we need to add 273, so 35 plus 273. And if you're putting all this, if you're putting it into the calculator just like this, you need to make sure you figure parentheses, or else you're gonna get a really bad number. And I get, what did y'all get? Thank you. We're 0.3 times, I'm just gonna say e to the -3. All right. 4 point, okay, we could use that just on total moles using PV with nRT and subtract the moles of neon. Maybe, that's, do you get the same answer? Because if so, then that's so much work for no. Bruh, that's crazy, Jake. Okay. So what Jake did, because Jake's actually smarter than me, right? Jake's found the total moles using, okay, so he knew that there's this amount of moles of neon, right? He used this to figure out. Wait a minute. Oh, I see. Okay, so you use the PV equals nRT with the total pressure, right? Which was PV equals, yeah, okay. Yeah, and then you found the moles of the total. And then you subtracted, yeah, that works, okay.
Oh, that is.
That's so
way-
much easier.
That's really hard. You.
I don't.
Oh my gosh.
My gosh.
Okay, I get it.
Okay, I'm gonna explain what they did, because that's a way better method. I don't know, I'm gonna change this whole answer here.
Yeah, thanks, Jake. That's a lifesaver.
Okay, so what Jake said is 626 millimeters of mercury is the total pressure, right? Let's convert that to atmospheres. So we already did that in step 3, right? So 0.82368 atmospheres is our P total, right? That's, we already know that. Now we use PV.
Sorry, he first, what did he do?
What was that?
Oh, he found the total mole.
Yeah,
Yes,
he found the total moles and just subtracted the moles.
Then he found the moles of neon. Then he
Yeah,
just pointed.
Jake is real different.
Wait,
Purple,
how do you
that's
do
fake.
that? By taking the total pressure.
Okay, so,
You just convert for the
so you just
total.
plugged everything 8, 2, 3, 6.
Did you make this problem doing
I
it?
did, and I'm trying to make a really hard problem, and maybe it's just my thought process of thinking about it in a really difficult way.
No, you're good, you're good.
Thank you. Okay, so then he said it's 0.355 liters over 0.0821. And then the temperature was 35 plus 273. And what did you get when you did that? 0.823. 355. Divided by 35. Okay, so I got 1.156. And then that's moles. Total, right? Now we're gonna subtract moles of neon that we found up here in step 1.
And that gives you moles of
Oh my
argon.
gosh.
Oh my gosh.
Hey, moral of the story, think smarter or work smarter, not harder.
No.
Okay. And then that should get you what? 7.23 times 10 to the minus. I got a negative number. I did something wrong. Okay,
7, 2, 3.
I might have put it in the calculator wrong,
It's
but
1.2. I think you're right. Well, it's not matching with the answer we got.
yeah, that's, oh wait, I know why. I don't know why I put a 0 right here.
Where?
There was an extra 0 right here.
Yeah, it's right. It's 0.
Okay.
And then 1.156 even in -2.
8, 2, wait, what do you say?
Like 18
The comments.
1.315. 0.0821. Divided by 35 plus 273. Equals 0.01 minus 7.23. Yeah, 2348. Times 10. Okay, yeah, okay, I got that. I got the same thing. Equals 4.3 times 10 to the negative. Yeah, hey, thank you, Jake. I don't know why I made that more complicated than it had to be. But yeah,
Okay, I got it too.
okay.
Crazy that you didn't do that away from the beginning.
Crazy it took. me so
Rich,
long
did
to
you do
talk
that?
about.
Yeah, I actually did the same word.
Oh my.
I mean, you can.
And you didn't even tell us.
You look at my work.
You literally let us suffer.
You really just let y'all go through that.
I cannot read this chicken scratch. Yeah, you just let us, you just watched it.
Hey, sometimes you gotta go through the pain in order to learn something. right?
Exactly. You guys will find that out on the next exam.
Oh my god.
I made a few of those questions. Let's just say y'all are gonna hate.
Oh.
Yeah. Yeah, okay. Just-
Can you at least respond to my emails if I have questions I can ask you?
Yeah, I mean.
Yeah.
I have a question about one of the conversions.
Yeah.
Were the millimeters of mercury?
Yeah,
Well, that's new to me.
okay, so millimeters of mercury is just a different way of, it's just a different unit of pressure.
That
Okay.
equals 1 mmHg equals 1 torr, right?
Yeah,
Yeah.
Okay.
that's exactly.
Did-
Okay.
Wait for the next question. Thanks.
So, okay, because I know the conversion from torr to BTM, but if it's just 1-to-1 for that, millimeters mercury to torr.
Yeah, yeah,
Okay.
okay.
Thank you.
Okay, last question I wanted to do is number 46. Anyone know how to do
Wait, number what?
46?
Find a, oh, it's the MCAT one. It's M, or is it the CCAT one?
It's coming to hot.
No, wait, it's
It's not like that.
This is this
Yeah, it's
agent B? It's enthalpy, which one is it?
MCAT.
Just find Q. Just find Q.
Yeah, but there's multiple equations with Q. Is it Q?
Yeah, but there's only one that you should use.
There's one equation in particular that you can be using.
All right,
We have not learned this.
I know. Okay,
That's what you should do.
you want us to cut off the session now?
Continue, continue.
Okay.
Continue,
Okay.
continue.
Okay, so you use this golden equation right here. Q equals MC delta T, where Q is your heat. Q is heat. M is your mass. C is your specific heat capacity. Now, normally this would be given to you, but in this case it isn't. So you should automatically know this value off the top of your head.
For water only.
Point, yes.
Yeah,
That sounds close enough.
for water, the C is 4.184. And then the units are right, joules per gram times 3 Celsius.
Or degrees Kelvin, it doesn't matter.
It says a specific heat what?
Specific heat capacity, yeah.
Thank you.
Yeah, it's a specific heat capacity. And then your delta T is your change in temperature.
Is that in Kelvin?
It can be in Celsius.
Change in
Kelvin.
temperature,
Yeah.
yeah, it's because it's just a change in, like, it doesn't matter.
Kelvin or Kelvin?
It can be whatever, so,
If the unit, like, they give you your heat capacity right in Kelvin, then your changing temperature will also be in Kelvin, they'll like cancel it out.
Yeah.
But since they gave it to you in Celsius, then like the change in temperature is also in Celsius.
Yeah.
Just to like cancel.
and why it doesn't matter is because a 10-degree difference in Kelvin is equal to a 10-degree difference in Celsius, it doesn't matter.
Okay,
Oh, yeah.
wait, what's specifically the water again?
4.184 joules per gram times degree Celsius.
And this is, so they haven't learned this yet, but this is this is the calorimetry.
Yeah,
equation
calorimetry.
You'll be using a lot.
Yeah.
Yes,
How do you say kind of what?
calorimetry.
Calorimetry.
Hey, very good, man. Pretty good. Okay, now,
So then now, right, it's just a matter of plugging and chugging your variables. So
The units there, it's here, sorry.
all the units right here.
joules, which is energy.
Yeah.
Divided by grams times degrees Celsius.
It's just to like a value to make all your other stuff cancel out. So if you get your Q right, you'll do Q and then M right. Yeah. So your heat's in joules and then your M right is 22 grams. Then your specific heat is 4.184 joules per gram times degree Celsius. Zoom right here. And then your temperature, right? Your change in temperature, how do you calculate that? Your delta T.
Final minus.
Yeah, final mass initial, exactly. So if it goes
Final
25,
beginning.
if it goes from 100 to 25, what's your delta T? Is that
Going from 100 to 25 or?
25 to 1? Same.
Here we go.
Yeah, positive. So that's 75 degrees Celsius.
Wait, so Q can be negative?
He can- Yeah, we can. You'll see that a lot actually in calorimetry.
'Cause,
We do-
Yeah, because if heat's negative, if heat's
Is peak be lost.
endergonic is delta G.
I know, I was just making a joke.
Exothermic.
Yeah, but you're not really,
Or
are you
endothermic.
releasing energy here?
Well, if it's negative, then that means heat's being lost by the
Yeah,
system.
and
Yes, you're
energonic.
losing.
Using energy in the
It's
form of heat.
exergonic if you're losing energy.
It's not exergonic, exothermic.
Oh, sorry, exothermic. No, you're not, you're.
Wait, if it's positive, is that endergonic?
Endothermic.
Endothermic.
It's whatever.
Positive is endothermic, negative is exothermic.
Exactly, I was right.
You got the idea halfway there.
You know, the other one like that one is like gives free energy and the other. No.
All right, so then, right, it's just a matter of canceling out your units. So your grams will cancel out. Your grams will cancel out. Your Celsius will cancel out. So all you're left with is joules at the end. So what you do is 22 times 4.184 times 75, and you'll get a Q that is 6,904. And that right there is your final answer.
Does it make sense that this is positive or?
Yeah, because it's endergonic.
And it's increasing in,
I'm just.
it's actually increasing in temperature, right? So it has to gain heat from the surroundings, therefore it's endothermic.
Yes.
They're actually the same thing. No, they are. They're technically.
We have to put answers in kilojoules or.
So usually, right, your Q, it'll have to be kilojoules, usually. So this, right, if you convert it to kilojoules, that's what? 6.904.
I don't know what. I'm just trying to get through this.
But again, this will be a multiple choice.
You'll probably find it.
You'll see the answer choices, if they're in joules, you have one answer, that's the kilojoules, the other one. All right, so that's the last question for today. Are there any other questions?
Wait, that's.
About notice or, hey, Maria, pull out your phone, go ahead and scan this rocket ship one here.
Okay.
Dylan, I didn't understand something.
Oh, yes.
Those guys get it?
How did the person in solve your problem?
I'm sorry, what was the question?
That other way that they solve your problem?
Okay, yeah. I don't think everyone.
I just want the curve.
Where's the height?
It's the one
Oh
on
my
the
god, I
right.
had to make that meme instead.
These two are on a plane and this is on a deck. Your height,
But yeah, any other questions on Zoom
The other
or
dash, you have to have a wedge, right?
in class?
You can't have all of you. Scoring dividers. This is your dad, right?
Yeah.
Are you ready for the Oregon? I'm actually reaching it. You ready for the Oregon camera?
Maybe, maybe not, depends. Prax exam was pretty easy.
I mean, organic is a GPA booster, right?
Yeah, the GP.
Why has 11 cents?
Whoa.
Everyone who takes it and talks, okay, see, y'all only hear the stories of the people that don't study.
That is, okay, honestly, it is fast. It is pretty fast.
You know,
I feel like
no,
sharing
I'm
my-
this story. Like praying for myself next year.
Yeah. I mean. First you gotta get past Gen 1 and 2, right?
Yeah.
So,
We all the TAs for Gen Chem too.
no,
I mean, I'm a source.
Did you become the TA?
he is, he's a star tutor for Gen 2.
Oh, yeah, that would be.
I have so many text messages from past students saying, I wish you were my TA again.
Oh,
Could do, but
Become
that's what we're
a
not-
TA for-
well, it's weird because this one doesn't have. to.
yeah, you should really.
But then I'm gonna take that guy. Okay, I'm gonna go ahead and end the Zoom, everything, if there's no more questions.
Them to go-
Thank you for that.
No, no, you're the same person that
We're
said
going
that
to-
to me.
Wait, who do y'all have, Perry?
Yes.
Yeah, RIP.